Oh, this is gonna fall.
Are you failing science? Is your mom yelling at you because you're failing science? We are not, brethren. I have come to save you. We will be learning how to name compounds.
Ouch.
We're back. So, we're going to grab our handy-dandy root and handy periodic table of the elements. First, let's define the different kinds of compounds. Ionic and covalent compounds. The first kind of compound is an ionic compound. I'm going to assume you have a somewhat extent of knowledge of physical science so you can understand this. An ionic compound is a bond between a metal and a non-metal. 1 second. My glasses aren't on. Let's just put these back on. Oh, ow, that hurt. So an ionic compound can conduct electricity, and it is also a bond between a metal and a non-metal. It is also an attraction between a cation and an anion. A cation is elements with the oxidation state of positives. And an anion is an element with the oxidation state of negative. Oh, I fell down. An example of this, of the attraction between a cation and an anion, sodium and boron. Sodium, which the element is Na, is +1, which makes it a cation. When boron over here is +3, which makes it an anion. So I realized I gave y'all incorrect information. Boron is a cation. It's not an anion. An anion would be oxygen, which is -2. Next is a covalent compound, because that's what we're here to learn today. We're learning naming compounds, not types of compounds. Okay, let me explain what we have on the board. A covalent compound is a bond formed between two nonmetals, and this bond is formed because of electrons sharing. Yeah. The electrons in a covalent bond are being shared, while in an ionic bond, the electrons would be losing. An example of a covalent bond is oxygen, O, and fluorine, F. A covalent bond would be OF. Oof. You may be wondering, Amelia, you changed your shirt. Why? Well, I had to eat dinner, which means I end that part of the video. I changed into another color of his shirt. It's still a sweater. Anyway, as I think I was saying before, ionic compounds. We need to learn prefixes. How are we going to do that? I'm going to tell them to you. Mono, 1, di, 2, tri, 3, tetra, 4, penta, 5, hexa, 6, hepta, 7, octa, 8, nona, 9, deca, 10. Simple. You're going to need to use these if you want to name ionic compounds. Simple enough, probably. Maybe not. Depends. Because I'm having just as much fun as you are. Also might be wondering, Amelia, you changed the color of your marker. Why, yes. I left my black marker out without the cap on, so it dried out. Well, my little dumplings, let's name ionic compounds. I filmed this video 3 times already. I've taught it wrong 3 times. So, ionic compounds, how do we name them? Well, I'm going to give you 2 formulas. One is written, one is not. And then I'm going to teach you how to do it. K4F3. In ionic compounds, you can just drop the subscript. So, now it's KF. And if we were to write it out, it would be potassium fluoride. And you might be wondering, Amelia, what's fluoride? Well, in a compound, especially in naming compounds, you need to add IDE. It's important. It's somewhere in my notes, probably. Okay, anyway, K4F3, otherwise known as potassium fluoride. And now in ionic compounds, you drop the prefixes. You just drop the prefixes. And then in oxygen fluoride, mind my spelling, it would just be OF, because those are the symbols for their elements. And there, now you know how to name ionic compounds. You should pass your next test. Covalent compounds. You need the prefixes for these, and also you need IDE. You need it. You're going to need it. For covalent compounds, you need IDE, and for these, you need the prefixes. And I'm going to give you 2 formulas, and I'm going to teach you how to name them. K2O3 and trimagnesium dioxide. Those are our 2 formulas. Let's start with K2O3. Ow, I just poked myself in the eye. So my glasses are crooked. K2O3. How are we going to name this compound? Let's name the covalent compound K2O3. So we are going to look at K. And remember, for covalent compounds, you got to remember the prefixes. Always remember them. So we're going to look at K and its subscript. So K2. And if you remember the prefixes, if you were smart enough to take notes, you remember 2 means di in science language. So K-di. Anyway, so K stands for potassium, so we're going to write dipotassium. And for the first element, you do not add IDE. E is reserved for the last element. So now we're going to look at oxygen and look at its subscript. Again, if you were taking notes, you would know 3 means tri. So trioxide. Don't forget the IDE. Underline it, circle it, star it, underline it again. Oops. Underline it some more until it's bright, bold, and beautiful. Bright, bold, and beautiful. Okay, trimagnesium dioxide. So for these, remember, you gotta remember the prefixes. Gotta remember them. So for naming a covalent compound or writing it in formula form, we're going to be writing it in this. So let's draw an arrow to it. To write in formula form, I don't even know if I'm using the correct terminology. But for trimagnesium dioxide, first look at the prefixes. Tri, di. Oh, that almost fell. So for trimagnesium, first, identify the element. The element is magnesium, obviously. But what's its name for? What do scientists use to stand for it? Well, let's pull out our handy-dandy root and tandy periodic table of the elements and see. So find magnesium, Mg, capital M, little g. Magnesium. And then look at its prefix. So then we're going to do a subscript 3. Then we're going to look at oxygen, dioxide, IDE. Underline it, circle it, star it, underline it some more. So first look at the prefix. It is di, which means 2. Oxygen is O on the handy-dandy root and tandy periodic table of the elements. So we're going to write a big O. And then a 2. So the whole formula should be Mg3O2. It might seem simple, but I don't know if you'll understand it. So when we're crossing and dropping, we're going to have a formula. You might be wondering, why do I need to cross and drop? The answer is because science tells us to. We do what science says. Science is scary. For cross and drop method, our subscripts start as superscripts, which just means they're above. So they think they're better than the rest of the subscripts. And cross them down to the bottom because we know they're not better than us. So when we do that, it should become CA3AR4. Because we switched them, we crossed, and we dropped them. They are now down to our level. That's how you cross and drop. That's all the science I know. Thank you for listening. If you did listen, I need to go finesse my way through 15 minutes of footage.